Good morning, everyone. We welcome you to Regain workshop. The workshop is about big data as key driver for circular digital transformation. And we are grateful to BDVA, all the Data Week sponsors and organizers for accepting our workshop and giving us the floor to share our ideas and our, we believe, promising propositions for advancing in the topic. The workshop is co-organized by the Universidad Politécnica de Madrid and the Data Mining and Simulation Group and Data and Web Science Laboratory from Aristotle University of Thessaloniki. And we are grateful to our speakers and our panelists who are colleagues and friends. And we are very glad we had the honor to participate with all of our speakers and our experts today in several projects. Some of the logos are here, which we believe highly contributed in the topic under the Horizon 2020 roof. In order to provide just the structure information of the workshop we envision to be an active one. And against, let's say, our social distancing, we would like to have a workshop that will be interactive with the audience. That's why we have 2 keynote speeches, which we will keep as brief as possible and to the point. And then we also have 2 panels. We have interaction with the audience with a quiz, which will start the next panel, panel 1. And then in the second panel, we provide the multi-sector view of the workshop. Of course, at the end, we have what we call artistic intervention to summarize the discussions of the workshop. And as I said, the vision we all share about the topic. So with no further ado, I will give the floor to Professor Ernestina Menasalvas from the Universidad Politécnica de Madrid to share with us a brief welcome and start with our first keynote. And I'm really grateful to her for supporting the work we have over the years. And as you probably noticed, of course, the keynote, the first keynote is about how the big data technology skills and competencies are needed in these critical circular and responsible business processes. And just very, very briefly for the audience, we have shared in the chat area the link of more information about the workshop. So if the audience would like to get some reference about the structure of the workshop, but also the speakers, the agenda, and so on, all the info is there. So Ernestina, the floor is yours. Thanks a lot.
Thank you, Athena. Thank you to all of our speakers. Thank you to BDVA and the organization for making this possible. And next, please. Yeah, so the first thing that we are going just to motivate this workshop, yesterday I was just reading a tweet in which it was saying that of the SME Alliance, in which it was saying that 9 out of 10 works of the future, in the future years, it will be digital. And today in the press release by the Digital SME, it was saying that the European Digital SME Alliance signs a memorandum of understanding with the Global Enabling Sustainability Initiative to ensure SME representation in the digital with the proposed framework for transformational service change of companies towards ICT-enabled sustainability. So this is what we are talking today. This is what this workshop is all about, how data science and artificial intelligence is driving the need of emerging skills in all the industry and society by large. So all the sectors are experiencing this transformation, and we need all the workforces to adapt. So all sectors, as I'm saying, from education to public institutions, they need just to adapt to the changing landscape and just to be aware of the evolving green and circular economy. So what we know is that there is still a skill gap when we talk about data and artificial intelligence. And the thing is that we don't only have to train our information and technology professional, but also we have to have interdisciplinary experts. So it is also just people that are non-technical that has to know about data science. We have to democratize data science, not only democratize data, but democratize the process, just to ensure that non-expert users have a basic understanding and awareness of what the systems of artificial intelligence are, how they operate, and which are the restrictions and constraints that we have to take into account. So the thing is that digital transformation requires new profiles, and specifically in IoT, big data, and cybersecurity. So what we are going to discuss is this evolving nature of data science skills that are required to deal with the big data and AI technology to enable, and we are going to enable a diverse group of cross-disciplinary stakeholders to discuss today about the skills challenges and opportunity for Europe. Next, please. So, well, the thing is that, of course, the skills, we need the skills on artificial intelligence and data science for a changing world. And we are envisioning artificial intelligence in a green circular society. So all the solutions that are based on artificial intelligence may require innovative business models that redefine the way in which stakeholders share investment, risk, know-how, data, and consequently, and this is the main important part of big data, value. So the thing is that many European organizations still lack the skills to manage and deploy systems of artificial intelligence. And the thing is that those regions in Europe that has the most vibrant AI landscape are the ones that are going to be best positioned just to attract the skilled professional. So what we need in this ecosystem of artificial intelligence, the system requires, on the one hand, organizations that will act as brokers that connect the supply and the demand for AI assets. On the other hand, they will require research and academics just to investigate on new algorithms, hardware, technologies, methodologies. And in this way, Europe is very well positioned. But the thing is that we need also the brokers just to connect all this that is being that just developed, all this that is being researched, and to connect with the demand. And so the skills are the enablers in the ecosystem of artificial intelligence innovation ecosystem. And we should drive them in the new emerging circular, share, attention, and green economies. Next, please. So which are the key topics that are going to be addressed? So we have to understand the AI skills challenge, just facing Europe both in terms of demand and supply, as I have already said, in this ever-changing circular economy and society. We have to ensure that in academies, we have the curricula that is the proper one to support the skill demands and to recognize the need for lifelong learning and vocational training. So it's not only a thing of just having our students in the academy, but also that people has to retrain, has to upscale, and we have just to ensure this lifelong learning in companies. So we have to support these efforts to train, retrain, up skills, and this is possible, and this will make possible to migrate to the digital economy sectors and to advance in research and innovation. We have to retain AI experts to ensure that Europe is an attractive place for artificial intelligence workers. And this is just also that we have interesting problems to solve, that companies have interesting sector to develop. And this is something that is not only part of the trainers, but also just a win-win situation with companies. And we have to encourage AI practitioners to have multidisciplinary skills. This is something that it is extremely important. And just because we need to assist the training for the non-experts in AI skills, as I was saying. Next, please. So which are the general goals? So the main goals that we have to think is that we have to understand, first of all, which are the industry skills requirements for AI and for non-AI workers. And we have to encourage the alignment of curricula and training programs with the industry needs, because otherwise the disalignment of academic will be just a horror. So we have just to make sure that we align. We have to create an ecosystem in which the industry, the academy, and the trainer suppliers in general work together in a win-win situation, ensuring that the best professionals serve as trainers of all professionals to acquire the AI training that they need. And of course, with an emphasis on circular and green awareness principles. And we have to establish AI recognition programs just to help companies also to contract the people with the proper training. And we have to develop citizen engagement. We have to raise awareness of AI and its impact and provide realistic demonstration of its capabilities and limitations. Now that we are also talking about, and that 2 weeks ago Europe was also launching all this ethical and just dealing with the privacy concerning and the use of AI. This is something we also have to create awareness, just to increase the awareness of AI, not only in the public, but also in the private organization with citizens. Okay, so, and this way we will stimulate all citizens in skills. Next, please. So concrete actions that has to be taken. So in the short terms, the SMEs will have to create awareness of the need of the transformation of this implication, and just realizing that incorporating data science in their businesses does not mean only to buy tools, but it's just to train employees and just to have cultural changes in the company. On the hand of policymakers at local, regional, national and European levels, in the short terms, they have to support and promote action to transform companies, just to boost innovation. And in the medium and long term, they will have to define strategic plans. And then on the sides of formal training institutions and training suppliers, in the short term, they have to encourage the quality of courses and the transparency of credentials. This is important for this accreditation that we were mentioning. And in the medium term, they have to work in conjunction with SMEs and large companies to support the demand. So this triangle is extremely important, SMEs, large companies, and academy in a win-win situation. And for large company, they have to promote a coordinated and integrated AI research community that is jointly committed to developing excellence in collaboration with industry and society. Thank you.
Thanks a lot, Ernestina. And indeed, we share the common, I was saying from the beginning, vision about how this will be established. So it is important really to look into those big data and AI skills and consider how they can become what we call actionable insights. Because it has been really observed that we are actually missing this multidisciplinary, holistic skill set, let's say. Coming from the academia sector, we can see that in the everyday life that we train our data scientists with technologies, with AI, but maybe they lack of the, let's say, ethical side of the use of data information. They lack of what happens out there in the overall ecosystem. So we need to join forces and proceed with what we call a data-driven culture, which will take and uptake the digital competencies and the data-related skill development under all of the umbrella of the green and circular society. Of course, this is in line with the goals coming from the European Commission about the Circular Economy Action Plan, which we have very carefully considered in this workshop, and all of the panelists and the key speakers really have considered how to accelerate the circularity on one hand, but on the other hand, driving the intelligence in an, let's say, ethical manner, respectful to the environment and respectful to the resources that we have around. Of course, there are several challenges in this vision because including citizens on one hand and coming from the academia on the other, and involving, as Ernestina mentioned, the SMEs, the large companies, it's a complicated task because we have multi-criteria coming from the different origins. So in order to look into those challenges and respond to them, we need to understand where we are. And we are trying to emphasize here that we lack actually of a data-driven, as we call it, business culture. Integrating the data science techniques into decision-making has started, of course, but definitely we are not sure that all of the issues of privacy, ethics, transparency, and security are there. As I said, these challenges were really puzzling concerns for all of us in the panel of this workshop, because we had strong participation in several projects. I will mention some of them at which we have participated together with most of, as I said, the panelists and speakers today, as an indication of what we can do and what we have started doing. And we would like to share this practice in order to, of course, open further dialogue. For example, in this project, Plastic Twist Horizon project, which aimed to actually revalue the use of plastics. We all know plastics had also a critical role to play in the COVID era. So many reports about how the use of plastic has raised and so on. So the question is, what is the data about it around? How is the data circulated? Is the data shared about the plastic, for example, use and about its revaluing? Of course, we had completed this project and we had the take-up messages being shared with the audience in academia, but also in Aristotle University, we have a citizen science hub at which we are trying the outcomes of an ICT project to become a more user-friendly and more close to the audience and the ecosystem. Another case of a more technical program which is going on, it's Project Rainbow, which actually is about big data technologies. And somebody might argue that it's a high-tech, let's say, project, and how can we consider the circularity here and this digital transformation and the skills that I've mentioned. What is important here is that we are looking into solutions which will actually save resources. And as it will be discussed in the next panel, this is a critical issue, and we are actually considering green data centers, and this is really, really important in order to integrate techniques and data sources which will be environment, let's say, friendly, and on one hand, and on the other hand, developing insightful skill set and competencies roadmaps about how the young generation of researchers, developers, entrepreneurs will really be cautious about these issues. Another case from the health domain is a project at which we have practiced data sharing about health records, about data that have to do with the patients themselves and the hospitals, of course. And again, at this project, there are certain challenges which should be considered about how we can prevent intrusion detection, but also how the machine learning threat detection techniques will be done in a way that, again, the whole processing for machine learning is not harmful to the environment. Again, we have carried several workshops like the one in Aristotle University in both our master's and PhD programs. We are trying also to embark as a group, but I mean all of the workshop participants and panelists group, we are trying to join key strategic programs in order to uptake green and circular skill set programs. And as you can see at this slide, we have prioritized only some of them Ernestina Menasalvas, Professor Ernestina Menasalvas is very, very active in this area and BDVA. And we are very closely working into looking on how these European skills, competencies could be, let's say, green, circular, and environmental friendly, because we need to, let's say, empower our young generation with a new way of thinking, at which we are not really going into the technologies with forgetting the environment and the social good. Of course, this is also done in accordance with the strategic SDG priorities, which we very carefully monitor. So this is, let's say, our thoughts and the keynote. We both thank you for participating. And I don't know if there are any questions from the audience. I guess maybe we would look at the end, the questions at the end, right? So since the time is really, really tight, we can go with the panel 1, right? We can go on with the agenda, I hope. Vasilis, is it okay if I can go on?
Yes, of course.
Yes, sure. So we are actually 2 minutes, I think we are a bit 4 minutes earlier than the agenda. So I don't know, maybe I will give the floor before we start panel 1. If any of the panelists would like to make a comment, just for 2 or 3 minutes, I think we can do that right now. Or Ernestina, if you have a closing remark.
No, yes, thank you. And we are just waiting for this enriching workshop in which we are very much expecting our speakers just for their talks. So thank you.
Thank you. Thank you. So let's go with then the agenda. The first panel, as I've mentioned, is actually targeting the theme of data, AI, cutting edge technology, and as we call it, again, of course, we have all the sponsors indicated everywhere. So the first panel is about data and AI, cutting edge technologies and circular economy crossroads. As I mentioned, my colleague Gounaris had some obligations, so I'm moderating this, and I'm honored to moderate this with our colleague Hanne-Louise Johannesen from Denmark, from Diffuse Design. So maybe Hanne-Louise, you can just say a few words for the audience, if you like.
Yes. Hello. Can you hear me?
Yes.
Yes. Okay. Yeah. Thank you very much, and thank you for the possibility to be involved in this really interesting project. So I'm really looking forward to see what the panelists have to say, and also we will start with this kind of untraditional format where Athena will introduce in a short while what we're going to do, but we wanted to include some kind of interaction with the public. So we hope that you find it interesting to play along and see if we can have an interesting discussion based on some response from you as an audience.
Thanks a lot, Hanne-Louise. Just to introduce the panelists, as we've mentioned, we are very grateful and proud that we have together in this workshop experts in their areas and very, very active researchers and scientists from all over the disciplines that are needed for the topic of the workshop. So the panelists for panel 1 is Professor Marios Dikaiakos from Computer Science Department at University of Cyprus, Mr. Artur Romão, who is the Director of Innovation and Development from Dexis in Portugal, Mrs. Danai Vergeti, who is a Senior Software Engineer in Ubitech in Greece, and also Dr. Nikos Kyriakoulis, who is a co-founder and managing partner of Core Innovation in Greece. All of the panelists, as I said, and the speakers have done remarkable and outstanding work, and their CVs are shared in our workshop website. So I encourage the audience to look into each of the CVs who indicate their really remarkable work. So we're really thankful to our panelists. And so as Hanne-Louise mentioned, we would like, let's say, to break the ice in this panel and try to open a dialogue with the audience. So we start the panel with a playful manner, let's say, and we have an interactive session at which the audience is very, very encouraged to play, let's say, in a game that is supported under the Kahoot platform. The rules of the game, I would say, are very, very simple. The game, first of all, is a game which has to do with question and answering. And of course, in order for each of the players to participate, you just have to visit kahoot.it. Once you visit kahoot.it, you have to enter a game pin. The game pin will be displayed exactly right after this slide by my colleague, Vasilis, and then you just type in a desired name, username. It should not be necessarily your name. You can type anything you like. So the quiz will start once player join in live, and it will start after 2 minutes. The game has 4 questions, and each of the questions has 4 possible answers. And of course, each of the users respond to it will have 60 seconds to choose one of the 4 possible answers. I believe the rules are clear enough. Actually, we decided to use Kahoot because we use it a lot, at least in our courses, and it seems to have a playful, let's say, character. So what is the idea? Out of those 4 questions, to get some input of the audience about your perceptions, your opinions of the critical matters that will be discussed by our experts in the panel. So let's start the game. So I will stop sharing, and Vasilis, you can start sharing and providing the PIN number. Okay, so just as I said before, the audience has just on a browser, on a mobile phone, wherever you are, you just type kahoot.it and you provide this PIN number once you are prompted there, right? Okay, so we wait for 2 minutes for the audience to join. So now the game actually starts. And this is the first question. So the question is, just to facilitate the process, which factors contributed to data centers' reduction of energy consumption contrary to predictions? Let's see what the audience thinks about that. And of course, you can see in our screen the correct answers, and in your browser you have the colors of each of the questions. So let's keep the statistics, let's say, about that, and let's actually consider the indications of the audience as driving the discussion right after that. So let's move on to the second question. As you can see, the second question is about what factor may be hindering the potential of public open data to help EU circular economy deliver relevant impact. And I hope you can see the answers. So again, it seems that the right, let's say, answer has been captured by most of the participants. Again, we keep the outcomes as a, let's say, input for the next discussion. So let's go on with the third question, which is about the impact of our data-driven decisions in wastewater treatment circular models. Okay, and again, it seems that the answer has been, let's say, really captured by most of the audience. So we move on to the final question. Which is about the zero defect and zero waste reduction. Is it a dream or a reality? And indicating, again, the factors which actually hinder the implementation the most. Okay, so once again, the audience did, let's say, respond with what was more or less expected. So let's conclude with our Kahoot game. The functionality at the end indicates the three most active of the audience and the three winners, which of course we cannot really place credit to because we just have nicknames here. But thank you all for participating. So we go now back, getting the feedback, let's say, from the audience. We go now to our panel, and I will give the floor to Hanne-Louise to maybe kick off the discussion with our panelists.
Yeah, thanks a lot to the audience for the different kind of answers. I think it was really interesting to see that we have this kind of aware audience, and they must have been listening very, very careful, maybe to what you said, but also in the keynote, but of course also have a very good knowledge about what is happening within this kind of environmental issues connected to big data and data centers. So it seems like there was some mostly right answers, but maybe Marius and Arthur, maybe you can comment on the runner-up questions and why you think that. I know that some of the answers might not be 100% direct. There could be discussions about if some of the other answers are about to be right or are coming there in time. So maybe Marius and Arthur, please give some info about what you think about the audience answers.
Yes, hi. Maybe I could start. It's great to be here. Thank you for the kind invitation. I think the audience missed the correct answer in the question about data centers because, data center, there are a lot of interesting things and opposing trends that go on right now with data centers. What we see is that there has been a significant improvement in energy efficiency of hyperscale data centers. Hyperscale data centers are the large ones that are operated and designed, built and operated by Google, Amazon, Microsoft, etc. And they went great strides to improve their efficiency. So the energy they are spending ends up in the machines that are doing the computations. And this has contributed to negating some predictions about the very high increase that data centers will have in the energy consumption and the environmental impact. On the other hand, we have new kinds of workloads, and that was the question that the audience got wrong. We have new workloads that are energy hungry. So maybe you have seen some recent news that, to train a machine learning model, and this is something that data centers do increasingly, it's a computation that takes a lot of energy, spends a lot of energy. Or doing mining of cryptocurrencies is also something that is becoming very popular as a workload, as a computation, and again, this spends a lot of energy. So on the one hand, we are building data centers that are very efficient in terms of energy. On the other hand, we have new kinds of workloads that are energy hungry. And then there is another recent trend which we will see emerging in the years ahead, which I think is very interesting, that hyperscale data centers are not the whole picture. So yes, we have these huge data centers, the optimized ones. They are going to go on. Microsoft expects to, to deploy tens or to hundreds of new data centers in the next years. On the other hand, we have edge and fog computing and the emergence of 5G. Which in order to work, we need to have micro data centers and nano data centers dispersed inside cities. And we also have the medium-sized data centers of academic institutions, research institutions, and so on. And achieving energy efficiency there is a different story. Just because of the engineering, and the amortization that you can do of energy efficiency measures across different workloads and across more or fewer machines. So, I mean, there is a lot of interesting trade-offs that emerge. And one driving force in reducing the footprint of data centers, the environmental footprint of data centers, is the use of renewable energy. And this is something that we have been working on, namely how to capitalize on solar energy in order to provide the power required for even small or medium size data centers. And of course, this is very promising because solar energy is becoming cheaper. So we see a rapid drop in prices, so it is competitive. It is an interdisciplinary endeavor. So what we did in a project that we developed a green data center was to work with electrical and mechanical engineers to do the design. And it is something that in order to work, you need data. So in order to be able to develop algorithms that you take into account on how you dispatch and you schedule workloads taking energy into account, or you even do different pricing schemes for cloud services based on what drives your computers, what energy drives your computers, solar, renewable, or brown energy. You need data, so you need to instrument everything, to put sensors in your production of energy production, in your energy consumption, in your mechanical equipment, and you need somehow to integrate all these different sensors and the data you retrieve from them in order to make them amenable to analytics and decision support. So this is in a nutshell, what I have in my slides. I don't know if we have time to show them, or it's up to you.
Yeah, maybe I think what you said right now was also very nice keyword for Arthur, and because you're talking about all this vast number of information and data that is streaming around, and then Arthur was commenting on the right question, maybe that there's not enough data, at least in the public domain, and to work with this openness. So we have this kind of a strange situation where we have too many data, but at the same time too few data. So maybe Arthur, can you take over, and then let's see if we have time for the slides later on in the session.
Okay.
Thank you very much.
Good morning, everyone, and thank you for having me here, and it's a real pleasure. Well, I would, if you don't mind, I would like to support my comments with a few slides that can illustrate it better. So, if you don't mind, I will share my screen now. Let me just see if I can find it here. Okay. So my question was about public data, or the question that my challenge, let's say, was about the sharing of public open data what it contributes and how it can contribute or not to take advantage of the potential of the circular economy in Europe. And I will just illustrate my comments with a few remarks, with a few some content from mostly European directives that might try to help us to understand, first of all, what was the right question, being that all the questions were the answers, were actually not wrong, but one of them is, I think it's more important than the others. But let me start by saying that regarding circular economy and why did I chose this subject to talk here. My company deals a lot with providing services based on sharing open data, so this is kind of like my zone of comfort. In regards to circular economy, I chose to show here a not so usual schema of the circular economy, because this one shows a very linear model of economy, but it identifies in which stages can we do reuse or recycling. Anyway, how can we do some circular movements here? But of course, in the end, there will always be waste. There will always be some leakage. So I find this schema more realistic than others that we are more used to see. And the thing here is that in all these stages and to take decisions on what to do, how to reuse, how to recycle out, and to monitor and measure the effectiveness of what we are doing in a circular model, data is paramount, of course. The thing about public data in this case is that it's data that is supposed to illustrate how the society, how the economy is doing. So we are not dependent on private data that can or cannot be present at the moment that we need it. And we have several principles by which we usually govern our understanding and our decision process regarding this kind of circular economy. I took a few of them from the French government that you have in there, can access later. So if public data should be so important in this process, what are the factors that might be hindering their full potential, that we perceive their full potential? That was the question, what the question was about, and the answers was just to allow us to briefly discuss each of them. So I'll start by the last one that was asked. Is there or is there not relevant or valuable enough public open data? I confess that I was a little bit surprised that this one was, let's say, ranked second in the answers from the audience, because that means that maybe I can help here, that in creating some perception of what is there already. I took the example of the European Data Portal, where if you access that link that is in there, you will find a catalog of data sets, many data sets, more than 1 million data sets from 36 countries. You can find some of them that for sure will have information, will have data that are relevant to the circular economy. Those are highlighted in the figure. And also, it's important to point that in a directive that has been recast now, it's I think it's the third version of it, the directive the 124 from 2019. The Commission identified a set of high-value data sets that most of them will, if properly worked on by the public entities that can provide data on them, for sure will provide the society, provide the circular economy operators with valuable information that they can use in their operations. So there is relevant and there is valuable public open data already there. You can browse it, you can find it. So it's not a question of not having data. Regarding the costs, and this is of course always a very hot topic. The same directive that I've just mentioned states that documents, and by documents here they mean data. It's just legal wording, but they shall be free of charge. But as it was implied in the answer, it's not necessarily for free, because there may be marginal costs that can be charged to the users or reusers. But it's expected to be as free as possible, or at least not so expensive. And on the other end, it should be noted that in a study that is also mentioned in there, there are several examples of public entities that found out that by not charging for their data, they would create a very positive effect in the economy that would amount to greater impacts than the fees that they are giving up on charging. So we can expect, or we should expect, that the cost factor is not that important in the future. Regarding the formats of data, this one I think was an easier one, because everyone is sharing data that has to be machine readable, or has to be processed, automatically processed. Otherwise, it's we can share, of course, data in PDF or in Word documents, but everyone understands that's not so useful. That's not where the value is. So I give you an example here from the same portal, from a data set that is from the government from Spain, in which they provide the same data set in 10 different formats. I didn't have space here to put the 10 different formats, so I think I'm missing 2. But anyway, they took the effort of providing this in as many formats as you wish, so that you can use it and not have a problem with these technical factors. So, and the directive also mentions that, and they say that they should comply with the FAIR principle of using data, and last but not least, comply with standards. So formats should not be also a problem on using data. So the question is, are there enough public entities publishing or sharing enough of their data? There should be, because they should comply. They should comply with the directive. But again, it's a matter of time. It's in time there will be, I'm sure, many public entities sharing their data of public interest. That is.
Can I ask you to summarize?
Okay, I'm just finishing. This is my last one. So yeah, just a brief note on that. In the European strategy for data, one of the common data spaces that the Commission has identified was exactly the one that deals with public administration data. So I think what we have in front of us in terms of strategy and policies is the right path. So we should expect that in time this factor will be less and less prominent. So thank you, and sorry for taking too much time.
Thank you very much, Arthur. I think you are very much in line with, or it is a nice bridge towards Danai, who had this focus on wastewater treatment in circular modules and data in that sense. So, and you had a lot of audience agreeing with you that all of the 3 answers above was right. So maybe please comment a little bit on that, Danai.
Yes. Okay. First of all, good morning, everyone. It is really fun doing this quiz, and I'm really happy that you find the right answer. Maybe I could also share my screen and share with you some slides. about so as to give you a better idea about the scenery. Yeah, just give me a minute. Okay. Sorry. Okay. So I hope you see my screen.
Not on the full screen. You need to swap displays.
Okay. Okay. Let me check again. Okay.
I think you can just share again.
So, how about now?
Yes.
Okay, good. So before commenting on the answers, I would like to give you an overview, to describe a little bit the scenery behind the wastewater treatment and circularity. So, so far, maybe we discuss about a very vertical matter in a vertical domain, but at the same time, it has a great impact on society and how data analysis can help in wastewater treatment and circularity. So currently, based on the statistics, the food production will have to increase by 50% to address the demands of the society by 2050. This is the food sector is a sector which is water intensive, and there are high demands of water there. So all this has a great pressure on society with economic volatility, social unrest and conflict. There are some regulations that have been taken place and have been and will apply from 2 years from now from the EU. So there is this need to go towards more circular directions. So regarding the circular usage of water, there is a lot of benefits there. As you can understand, we minimize the risk of water shortage, but at the same time, we maintain the value of water. And also there is another aspect that we as data scientists can help in, that is the valorization of the dissolved matter, meaning finding other added value components that can be later on reused. I will explain in a few minutes. Now, the wastewater treatment is an activity which is a need, and it is required in water-intensive activities, as I said before, in a number of industries. It is a process which takes place in phases. So there is a pre-treatment phase where the water is pre-processed. There is a phase where we extract value-added compounds. Then there is the wastewater treatment itself, and then there is the circular usage of the outcome of this process. Now, what we can do by bringing data science in all these procedures to further enhance circularity and assist the experts in transforming what we call as intermediate waste of these phases to something valuable for usability from a number of use cases. So how we do it? There is a lot of things that there's a number of things that we can do in order to assist and enhance this process. First of all, there is the most obvious thing is to go and get data from each of these stages that I mentioned before, and to draw some light and assist the experts to to identify and see valuable insights on the data so as to proceed with decision making. What we could do is to create and to use machine learning and deep learning approaches, as well as rule-based engines and other software tools in order to collect the data, process them, and then later on assist the users to their decisions. If we go into if we dive more deeply into how we could, in what we could use, throughout this process, there is a number of data that can be used, and they are currently measured through conventional means. But what we could do is we could collect them, and we could perform analysis on this data. These are real-time data which can come from sensors that can be integrated into the infrastructure which performs wastewater treatment, as well as historical data. So far in the market, there are a lot of, and also in bibliography, there are a lot of, there is a number of work that has been done which draw some light on real-time data analysis, but there is this need also to combine the real-time data with historical data so as to do more complex analysis on this process. Also, there are some external data sources that can be used, like water data or freshwater availability. This is a need that comes from the domain experts, that there is this need to somehow combine what happens in real time with the seasonality of some activities that are performed by the customers.
So can you wrap up?
Yes. Okay.
Thank you.
Okay. So all this is focusing on optimizing the wastewater treatment process with regards to water quality, as well as the conditions of the wastewater treatment, and this can go even also cover aspects like predictive maintenance on the infrastructure itself. So you were all right about your answers. There is a number of, by doing all this procedure that I mentioned before, there is a number of problems that we can solve. First of all, it is the optimization of the circular approaches that we apply so far. Then we could further assist the domain experts in order to further exploit the intermediate outcomes of this process. And all this can also lead to another social, to the social impact, to the larger impact of these processes, is that we encourage all the stakeholders to perform synergies and develop further circular models in order to improve their final products. So more or less, this is what I would like to mention. I don't know if you have any questions.
I think we need to hurry further to make sure that Nikos is also able to come with some comments. I think we are already lacking time. It's really interesting, but please stop sharing your screen, and then I would like to give the word to Nikos and see if he has some dream or reality check that he wants to share with us.
Okay, let's see. First of all, thank you all very much for the invitation and the excellent organization. I know that I'm delaying you for something really important, which is the coffee break. I've been there many times. So let me know if you see my screen. Can you see my screen?
Yes.
Full screen, right?
Yes.
Okay.
Yes.
Perfect.
Yes, Nikos.
So again, I think everything is connected, and just to make a fast wrap up from the previous speakers, I think we're all speaking about the same things, but have a different perspective in mind. But at least myself, I noticed that everything is connected and linked together, and the same principles are there, whatever we discuss about. Either it's circular data, open data, wastewater treatment, and about what I'm going to tell you. So zero defect and zero waste production, is it a dream or a reality? Let's see. Before we begin, I always try to take one step back and say, okay, what we are talking about, what is zero defect manufacturing? Actually, it's what the name suggests. Imagine that everything, all units, all products, all the goods that you are producing are 100% right, everything. So everything is inside the acceptable quality limits. This is what it means, which is impossible, as you may know. We have some defects. We all have both products that did have some defects, right? So in case we find there are some defects, what can we do? First of all is, let's see how we can identify them. And then if we identify them, we have to remove them from the production line in order not to reach the customer, right? And what can we do? If it's the material is repairable, we can try to identify what is the best remedial action. Let's see, make a patch or screw a drive or make a welding, and have at the end of the day zero defect. The ones that are not repairable, I'm afraid that they are going to waste, which is not a good thing, right? So let's see what is zero waste manufacturing or production is what we discussed before. So we have no defects, no scrap, no something or removed material to the entire life cycle. It's what Artur displayed some slides before, these circular loops. So I have a mnemonic rule for you, don't bother, it's downtime, and which is everything is bad, remember the sign. So defects we discussed about, overproduction is not a good thing, we need to produce what we need to sell, right? So if we don't have good quality and I need to sell 100 products, imagine how much I have to produce, like 150, in order to have at the end the right amount of products, right? Waiting time, imagine yourself being stuck in the traffic. It's a waste of resources, waste of energy, and you are just waiting, which is not productive at the end of the day, sorry. Non-utilized talent. Humans are really important. They have super experience and we need them in the loop. We don't need them to put them on the side, but put them on the forefront. So all these nice technologies that we will discuss have to put a human in the center. Transport, it's maybe cheaper to produce something in China or a cheaper country, but the transportation cost and the energy and the resources that are required are much higher. So it's not a good thing. It's a waste at the end of the day, right? And inventory, imagine that the more products you produce, as we discussed before, and the ones that you have as substitutes or backup plans require warehouses. So inventory is a big waste of resources. So it's not always good. Motion, the less motion we have inside the manufacturing shop floor is safer. First, it eliminates the possibility of having defective products through to accidents and so on. And last, but definitely not least, excessive processing. Sometimes the parameters are not right, so we overuse or let's say have an excessive energy or excessive material disposal working on a product, which is a waste, and I'm afraid we cannot do something. So having said all that, a reasonable question, what data are required to solve this? I think it's quite straightforward. And usually I do the question and wait for an answer, and here are some that I filed. Now I'm afraid that I answer and I give the questions and I answer myself. So it's first we need to know what product we need to design. So it's the computer-aided drawing and engineering and manufacturing. What parameters we need to have in order to produce it right. We need to check that the machine have to be up and running and in a good health. And we don't want to produce something and identify at the end of the day that has a defect or it's a problematic product. We need to have inline sensors for quality. Of course, quality control is something unique. We need to have in every stage, let's say, to check the quality, not at the very end or somewhere random in between. How we make sure that the machine is up and running, we need to have sensors. Any alarm triggered, false positives, false negatives is important to know. And of course, the material itself has some process parameters about heating and how it needs to be treated. So the technologies, as you may see from the image, Industry 4.0 is the answer. And just to make a small list is we need to take data from Internet of Things and data aggregators. Machine learning, as we discussed before, we need to train and predict what is going on. Virtual twins to simulate 5G for fast transmission of data. Decision support systems to help the human put them in the center. And cloud computing that are necessary to have the processing wherever it needs to be done. And of course, distributed ledger technologies and blockchain technologies for traceability and make this reusability and circularity easier. So one big problem is who has ownership over the data. We have faced it many times, and it's not an easy answer. Is it the machine user? Is it the machine builder, the one that produced the machine, or the machine owner? Imagine that I own a machine and you lease it from me. So who has access to the data and who has access to publish the data? Sensor IT providers are also have, let's say, ownership over the data. The solution provider either for predictive maintenance or condition monitoring. And the one company that actually does have access to all the data is security companies. And we give them access freely. So imagine that the same amount of data are being shared to many people. And here we come up to the three questions that we discussed before. So there are the know-how and the technologies, but unfortunately there is no solution to fit all. So I'm afraid that we need to find ways to make something horizontal and have it better integration. So we have a bit of insufficient of integrated technologies, but not the core technologies. Low awareness about the benefits usually delay investments in adopting these Industry 4.0 technologies. And this is really important and connected to the next. So is a lack of standards, legislation. It's not, let's say, imposed by the law to have circularity. It's not imposed by the law to have green products or have zero waste or zero defects. It's basically monetary, unfortunately, at the moment. And plus the factor that we have highly vertical solutions. Each solution is unique, so it has a tailor-made requirement. Usually have the delay of the adoption. So as you see, the questions are, yes.
I was just asking if that is your conclusion, because...
no, I have 3 more slides. I will wrap up. So
yeah, okay. The problem, we have a big time problem.
Okay, so some numerics, just give me 30 seconds that I will wrap up.
Okay.
So here are some, the adoption rates in the big players. Only 6% are completely digitalized globally. And the market is growing, as you see. A paradox is that although the funding and the market is growing, there is insufficient investments. 80% of the technologies and the companies indicate that the investors lack expertise to assess the deep tech potential. So everything is delayed. So this is my final remark. So it's not a reality yet, but definitely it's not a dream. I think in the future we will witness it. And that's it all from me. Thank you very much for your patience. I hope I didn't delay you.
Yeah, well, we together we ate up our break, but I think it was really interesting, and I wanted to hear more from all of you. Yeah, lack of time. But let's keep on dreaming at least, or at least try to make sure that the dreams come true. So I don't know. We have used our break, so maybe we just need to continue.
If I can suggest, Hanne-Louise, maybe we can have a 5 minutes break, and let's all try to be back 11:50.
Yes, good.
Okay.
Yeah, thanks.
Apologies for the delay. Yes, a really interesting panel. Many thanks to all. Okay, so we come back in 11:50. So we are back. Apologies for the very brief break, but there are so many things to discuss. And I believe that after our very, very interesting panel, which indicated that we have data centers on one hand, we have the open data and the policy making that is needed. We have water, environmental footprint issues, and we have zero defect and manufacturing, of course, goals. We move on to our keynote talk provided by Dr. Sotiris Koussouris. Sotiris represents a very active company, Suite 5, which is in Cyprus and provides data intelligence solutions. And indeed, Sotiris, it will be great to listen to what you have to share with our audience about how the data technologies from cloud to edge could be exploited for further circular economy opportunities. Thank you, Sotiris, for supporting the workshop. The floor is yours.
Thank you, Athena, and thank you for the good words and the nice introduction. I will try just to share my screen. So I hope it works. I can see from my side it works.
It works. It works, yes.
Hello, everybody, and welcome to this second stage of this very interesting workshop. Today, I'm gonna try to briefly discuss about how data technologies that are used on the cloud from the edge to the actual public or private cloud infrastructures can help circular economy. What are some of the things that one has to consider, and what are the needs out of these data technologies in order to make all this dream or a reality? So we talked before about dreams and realities. So in our view, we're not there to a full reality, but the dream can become true. For that, of course, everybody needs to contribute. Technology has to move forward, and also other things that are quite closely coupled with technology, like legislation, strategy, policies, and of course the will of the people to share. And having said that, as we all know, circular economy can take a lot of forms, as you see in this factor, but the main thing that needs to be there is the will and the motives to actually share and trade the information that is needed. Typically in circular economies, the goal is to prolong the lifetime of products or services, to build extra value on top of those existing products or services, build value from residuals, transform then the products back into raw materials and so on. But all for this to happen, as I said, information and knowledge needs actually to be collected from different entities, from different sources, and from different locations, in many times different paces. So remember the V's of the big data, as we call them: volume, velocity, variety, and so on. And all this is something that has to be infused into a circular economy ecosystem and distributed to different knowledge centers and operations. So there needs to be actually a data flow which can and should be then translated into a value flow. So talking about this flow and actually the types of circular economy ecosystem, one can think probably of many types. So I have just 3 here, which I find quite, let's say, dominant. The first one is a circular economy, which is actually being executed by a sole actor. So that's typically not the case. Actually, this is something that we seldom see and come across, but there are enterprises that actually do have such types or such circular economy flows, where the whole system, if we may say that, is actually governed and by the corporation itself, and the main goal and the motive is to improve the value of the services and the products provided, improve the value for the company, and actually keep all this value within the organization. So a typical example of such an actor or such an economic could be seen if we think about how Apple utilizes their iPhone product line, where they go beyond just selling the product and providing services, but they do have some active channels where you can bring back your old device, then it gets dismantled. Some of those are refurbished, or the components are there used in new products and other services, or are recycled. So this is handled, let's say, entirely by them. So this could be like a sole actor. Nevertheless, this is not the most interesting type, as everybody can guess. We do have other types, like closed ecosystems, where the overall flow is actually controlled by some entities of those ecosystems. The main objectives remain the same: improve the value of the products and services, but there are also other benefits, like co-design at network level of those products, of the services, or of extra things that could be added on top. And the value is also distributed to the different collaborators in that network, so it's not just kept for the sake of one. And then, of course, we have the open ecosystems, where circular economy can take place. Actually, this is the most interesting thing, and this is something that is the most challenging at the moment. The idea there is actually to max out the value of a product of a service, and this can happen actually through open innovation. So data and information should be there and should be actually shared, and then innovations on top of this data can be provided by everybody who is interested to become part of such a network graph. So the value is distributed to all, to everybody that is actually taking place, and new data cash flows can be generated. So thinking about that, we see that when we move from the left of this picture to the right, so from the sole actors to the open ecosystem, of course, the value and the innovation that is there evidently increases. While on the other side, as you know, data and information is shared, trust and control, unfortunately, is decreasing. And this is actually one of the main problems that data technologies have to solve, because they have to balance trust, control, and security with value generation. So we need to have technologies and methods in place that will actually take the most out of this, you know, two ends. And I'm saying that because we believe that data sharing is actually fundamental for a circular economy. So it cannot work in silos. There are a few exemptions, as I mentioned, but in general, in order to make this dream happen, we need to actually start diffusing the knowledge and sharing it, and of course have, you know, the motives that would allow everybody to onboard such ecosystems and play the role they're supposed to, either to provide the data, analyze the data, manage the data, or consume the data in order to deliver that extra value that is needed. So thinking about that, and thinking about that data has to be spread around, and many organizations have to, you know, collaborate and come together, then inevitably we talk about the cloud and the cloud continuum. So not just, you know, simple cloud infrastructures, but the whole cloud continuum from the edge to the fog and the actual cloud, as we call it. And there we have, of course, the questions that go hand in hand from the data perspective that have to do with where to offload the data, and where to manage and analyze the data and so on, which actually impose other sub-questions like how valuable is the data to me in order to deposit it on a cloud infrastructure, or how big the data is. Can I do it? How complex the data is. Will it be manageable by that systems? Nevertheless, if we have, if we see the same graph again as we had with the circular economy, we see that the main things here are actually happening. As much value is stored and processed on the cloud, this creates value for the whole ecosystem. But of course, when data is residing at the edge or on premise, of course, security and trust of those data relevant operation is quite higher. So actually, if we break it also down into the sub-questions that I've said, we can see that more or less there are relevant issues to be discussed when talking about the edge or even on-premise operation and about cloud-based operations. Just some examples. What about data access? Data access is quite easily performed on-premise. There you might probably not have any kind of data access policies if you are just a single enterprise, but it becomes harder when you have to trust people that operate in other environments. So you have to bring into the picture crypto and security, and those independently pose some great obstacles like latency or resources that are necessary in order to decrypt data and provide the data with different keys to different stakeholders and so on. Moving on to the analytics or AI or ML, or call it just data management and handling. Then when we're talking about the edge, of course, there we have just some examples, for example, low latency. But when we move to cloud, cloud operations, there we can have bigger delays when it comes to propagating the data to the data consumer, but the models that we can run there can be quite more complex, and the results could be quite more accurate because you can actually handle more data. And again, with decisions, data-driven decisions, at the end, you can take quite faster and decisions like, getting data and information out of IoT and quickly processing them towards letting a machine know what to do. But when this information has to go over the cloud, there you can have better informed decisions because you can also blend information and intelligence from other sources. So what should be, let's say, in a golden box that the data world has to offer to, ecosystems that actually bring forward circular economy? So first of all, we need methods and mechanisms that would allow to attribute in a fair way the value to the data owners. This is one of the most important things because as we see, also I think that was a question in the game. There is a reluctance from data owners to share data. So you have to give them actually motives and compensate them in some ways in order to do that. And this will actually open up the doors to build such ecosystems because data will be provided and would be beneficial to all. Of course, this goes hand in hand with flexible methods for sharing this data. And of course, intelligent methods that are going to actually allow to get access on this data and actually manage the data in such ways where extra value could be generated. And this goes from simple data transformations to enrichment, semantic enrichment, data linking, and so on. And of course, then all these data assets needs to be discoverable over over the cloud and available to everybody that has an idea and could build on them. And of course, there need to be the tools that would allow the actual protection of the IPRs and the protection of the usage permission that are given by the data owners. So we're talking actually about smart contracts that should supervise such transactions and should supervise also how data is used, which is something that is quite fertile ground at the moment, as it requires actually blending a lot of legislation with data technologies. So the way to move forward, as we see it, is actually to provide some hybrid infrastructures where circular economy is performed over a mix of cloud-based and on-premise environments. And this is in order to take out the best out of the two worlds, as we said previously. So you could use the cloud in order to perform all the necessary operations that have to do with transformation, sharing, providing the necessary resources for cryptography or for conducting quite accurate analytics in secure and privacy-preserving and trusted containers. But of course, there needs to be also on-premise environments that communicate with such infrastructures in order to not only collect the data and share it, but also to perform the local operations that have to do with encryption or decryption, if we talk about data that should not be shared as is, about localized analytics in cases that you seek more robust and rapid results, and so on, or if in such a case you care a lot about providing private information on cloud environments, and you are still reluctant to do that even in secure and trusted containers. So summing up, what we feel is next for data technologies and how they should contribute is that they should become quite more flexible, robust, and performance across the whole cloud continuum. We see at the moment that there are very good examples and performant technologies that can run on the cloud or on the edge, but more is still to come. And these actually are things that are coming. I will just mention here the example of federated learning, where machine learning is performed locally instead of being on the cloud. So, and it's quite performant even at this stage. Then data technologies need to converge with IPR management and data protection issues, and actually there should converge with legislation. But this also is a request also from the for the legislation world to catch up with the innovations of technology. So there is a huge gap. So data and actually IT technology moves at a very fast pace when compared to legislation. And finally, we need to continue work on open standards. So in order to be able to bundle all the things together and allow interoperability, but provide also legacy support, as there are too many systems at the moment that do hold data and they are based on legacy standards, and those have to be supported in order to actually extract the value. So that would be all from my side. I hope I didn't take too much time. And I would be happy to take part in the discussion at the end. Thank you very much.
Thank you, Sotiris, and thank you for being more or less on time. I know we have so many things to share and the time is very limited. We will keep certainly the questions for the end. And just to inform those who have joined now, we are now moving on to our second panel. And at the end, at the conclusion sections, we will have an intervention which will be, let's say, more creative. Our next discussion panel is about now on how the sector highlights could be indicated. Let's say we go a bit to vertical sectors, and we are honored to have with us as moderators Ms. Manon van Leven. She is an expert with whom we have worked many years now from EOLA, Spain, and Professor George Pallis from Computer Science Department, University of Cyprus. Both of our colleagues are really experts in their area. So I will give the floor to Manon to go on with the second panel. Thanks a lot.
Thank you, Athena, and thank you for the invitation. As we're already a bit late, and I think the panelists have much more to say than I do, I will briefly introduce them, and George, my colleague, he will moderate the question session at the end. Now, as you have heard, you can see the CVs of our panelists on the workshop website. So I would like to introduce them in a slightly different manner. Really, really proud to have the following panelists with us today. We have Leila. She's a data and nature enthusiast, and she's a really talented amateur photographer. We have Philippos. Philippos thinks that chance has its reasons, and he prefers perplexity over enlightenment. We have Serge, who's working in the field of farm to fork, not only professionally, but he also enjoys getting that physically to himself. And last but not least, we have Harris. He thinks that imagination brings us beyond our limits, and he works in also in relation to food. So without further ado, I would like to move the word on to our panelists and give them the floor. They are our stars today. Thank you.
So thank you, Manon. So it's a privilege for me to be in this rigging workshop together with all panelists here. And so I share my screen and start my presentation. So I'm starting my presentation with a very short video.
Yes, I am. Plastics. Exactly how do you mean? There's a great future in plastics. Think about it. Will you think about it? Yes, I will. Enough said. That's a deal.
In the film Graduate, which was filmed in 1967, McGuire takes Ben aside at the party and says he has one word, plastics. Here, plastics is understood to mean a cheap, sterile, ugly, and meaningless way of life, boring about the values of the older generation. Today, after so many years, about 8 million metric tons of plastic are thrown into the ocean annually. By 2050, oceans will contain more plastics than fish, and the entire plastics industry could be consuming 20% of the total oil production and 15% of the annual carbon budget. The question is what to do together for a world without plastic. How we should act globally. The answer is the new plastic economy. The current economic models generate costs and doesn't solve the plastics problem and creates more. It's a matter of use of resource. We have produced so much plastic products, so why not using them as a resource for the next one, instead of producing virgin plastics? A so-called the new plastic economy by the World Economic Forum sets targets for the circular economy. Plastic is cheap, flexible, and resilient, and there is more demand for it than any other material nowadays. You never get worried when a plastic bag flies away from your hands. You do not run after, but it was your diamond ring. Would you behave the same? Although the calculations seem to be made to revalue plastics, at the moment, there is still no meaningful relationship between the costs that producers and consumers pay for plastics and the global environmental impact of the material. This reflects a failure of the financial system. So we designed it differently by developing Plastic Twist platform. We designed a Plastic Twist marketplace. In this marketplace, you can exchange goods, support projects with material and services where plastic is reused or recycled. In our platform, Twisted Plastic is an environmental asset that is tracked, measured, and verified so that it can be used by any interested user, could be individuals, companies, industries, for sustainability and environmental responsibility. And accordingly, we set up 5 elements that decide the twist value: people, innovation, material, transport, and impact. In the platform, twisting the plastic is intensified by tokens. The calculation of the token is based on a method from environmental science using these 5 elements. It reflects the dimensions that the material has in a sustainable practice, and we are tokenizing actually plastic. This is what we are doing. We provide tokens for projects and products that allow plastic reuse. At the end, the plastics cycle is the data value chain of the sustainable plastic reuse of plastics. Monetizing and intensifying and sustainable reuse of plastics by twist tokens. Data is harvested in this value chain, and the correlations are comprehensive. The relationship between the costs that producers and consumers pay for plastic and the global environmental impact of the material can be tracked. Plastic Twist defines the value of plastics in 5 dimensions by creating data, by answering some questions. For example, how many people are actively involved in this? Is this idea new, easier, and communicate? What plastic is it? What are the recycling properties? How far must the material be transported? And by which means? How much material is removed from the environment? Plastic Twist platform brings together supply and demand for recyclable material. Material is the key, is the core, but also for expertise and products where its value is calculated. The blockchain is the solution infrastructure for this platform, providing safety and transparency and the open data. So the virtual information block is plastic block in the process. We better track and understand plastics by data. Data is shared openly that can be used by plastic recyclers, producers, innovators, academics, economists, and data analysts. In Plastic Twist, we created an ecosystem engaging a long-term project profiting from concrete uses of recycled plastic, as well as participating in both supporting the reuse of plastic waste and accelerating new circular use of plastics. Especially grassroots initiatives have been a lot important in this ecosystem. The approach are on participatory innovation, new ways to produce collective intelligence in key sustainability areas, and by leveraging open data, knowledge networks, and digital social innovation. Twisting by learning and earning is the circular digital transformation. So, blockchain. So this is the structure of the platform. It offers a composite structure providing open data, value chain, community, collaboration, and creating an alternative plastic economy based on sustainable material for future use. You can earn twists in your wallet, spend them on the plastic twist marketplace, supporting a maker who will give you her products with the plastic twist certification that your purchase has removed plastic from the environment. So this is our plastic token wallet that can be used for the platform. The platform was initially a project that we were a consortium of 9 European partners who developed the platform and supported by the European Commission Horizon 2020 program. And I also give a special thanks to Istanbul Blockchain Women Association for the operations after the support after the project. So it is sure that the goals on solving serious global issues can only be achieved by collaborating, creating awareness on people, by creating and using emerging data value chains, and so by creating a social impact. So this is all I can say. Thank you very much, and open to your questions.
Thank you very much, Leila. However, very interesting presentation, and the project is really very nice project. However, I'm afraid that we don't have the time for questions in this panel, so we will go to Dr. Philippos Papadopoulos for his presentation.
Hello, let me share my screen. Yes. Okay, I don't know if I can make it slideshow, so not to waste too much time, I'll continue like this. Thank you for having me. The main role of American Farm School and my office in particular is that of an innovation facilitator. Today I'll present our use case, starting with the cluster that has been established recently. It's called INOFA, Internet of Food Alliance. It's a vertically integrated innovation cluster, more than 70 members, covers the whole agri-food value chain, and it's supported by a number of RTOs and service providers. The overall aim is to facilitate traceability, sustainability, including, of course, the circular economy, through the use of digital technologies. And the main integrating technology of this internet is LoRaWAN telecommunications. Now, to connect this with issues raised previously, both by Ernestina and by Athena, we've gone through a small exercise of evaluating digital maturity of our members, especially the real economy providers. What emerges quite clearly is that there is an awareness on the part of both businessmen and farmers for cultural change in order to adopt digital technologies and data exchange, which of course raises the further question of interdisciplinarity, which was already mentioned. In this case, I would like to stress that issues of culture, of organizational culture, are of course behavioral issues, which in turn means that our understanding of interdisciplinarity should include the social science. We are experimenting, or we have introduced social scientists in our office, and they seem to be working fine with agronomists and so on, for the time being at least. Now, moving back to the more technical aspect, though I must stress that I'm a layman, Okay, I'm not a tech person myself. We have established a LoRa network comprising of 12 weather stations, gateways, and we have a capacity of serving about 50 to 60,000 sensors. It covers the whole of Greece with emphasis on northern Greece, but also presence in Peloponnese and in Creta. We gather all that information and we store it in a central cloud, and then process it and utilize it for customized consultancy on the basis of algorithms developed by us, and also for automation. Now here perhaps is the best place to raise the issue of the legal aspect of what we're doing. As an innovation facilitator, we have discovered to our cost that working on a project-driven approach has the inherent problem of periodicity of revenue. So we are trying to move to a service-driven model, to a new business model, which of course raises serious legal issues regarding the security, the quality, and IPR of data. That's been said before. One aspect of this I would like to highlight is not so much the relationship between the data owners, let's say, the farmers, and the data processors, the consultants, but the relationship between both of these groups and the connectivity provider with the cloud owner. To be quite honest with you, I can see myself going through a legal battle with farmers. I cannot see myself winning a legal battle against Bill Gates. So this is an issue of balance of power that I think at some stage has to be addressed by the European Union. Now, the challenges that we face as an innovation facilitator working within a cluster and with a network, a telecommunications network, is first of all data robustness. We are supported in this by Data Lab, Aristotle University. My friend Tassos Gounaris uses the expression dirty data quite a lot, which doesn't do any good to our ego. But I guess this is a big issue. Second issue is, hardware resilience, especially working outdoors with harsh weather conditions, with problems of hardware being damaged by wildlife. And by that, I usually, we have to face problems with mice and boar and stuff like that. There is the issue of internet connectivity in the rural areas, which forces us to start experimenting with satellite connectivity. And finally, perhaps the most important in this sense is the communication issues that we face between tech people, agronomists, and farmers. There seems to be a serious communication gap, perhaps resulting from skill gaps there. We've taken some steps to rectify things, some first steps. For instance, we are co-organizing with the informatics lab of Aristotle University and the International Hellenic University, the agronomists of the latter, presentations to students who are tomorrow's agronomists to help them understand the digital and data side of things. What I would like to stress here is that to overcome this problem, we should not see it as simply a skill gap issue. We must also see it in terms of career pathways. We must appreciate the fact that people who don't feel comfortable with the new digital age, they're not going to be passive. They actively negate it. So for instance, I have professional agronomists who have everyday communications with the farmers, who actually don't feel comfortable with digital technologies and who advise the farmers that all this is useless. So it's very difficult for somebody who is in the city and meets farmers once every month to counter these kind of arguments. So we must follow an inclusive approach that has everybody involved and everybody being able to see a future for them personally in the new digital age. That will be all for me. Thank you very much. I'll stop sharing now.
Thank you very much. Unfortunately, we don't have the time for questions, although what you presented us was very interesting. I would ask Dr. Zran to
okay.
Your presentation. Or
Thanks. Yeah, I didn't prepare the slides. I think it's short enough. We can do it without slides. So the name is Srđan Krčo. I know it's awfully difficult to pronounce it, although some of the Greek names are not easy either. So we are equal, I guess, there. I wanted to talk about two projects that we were involved that are related to circular economy, and one hopefully to become a project. But I was planning to start with Target Smart, the project that was that we did a few years back. Now, listening to Philippos, I think I can just follow up on that and talk about Demeter project, which is one of these large-scale Horizon 2020 projects related to smart agriculture. There are like 60 partners and 20 plus different pilots across Europe. And the challenges that Philippos raised there about the communication gap and the robustness and all these things, that's something that is it's well identified, and it's something that has been observed by us as well in the project and also in our commercial activities. And that is definitely a big challenge. When we started to talk about smart agriculture some years back, it was like talking about some distant future, and people were just listening and saying, "Oh, that's fine, that will happen somewhere else, not here in our region." And we are based in Serbia, so covering similar region. But nowadays, after a lot of discussions, a lot of talks, explanations, we see now that the farmers are starting to catch up, and they are more and more interested in all these things. And when they see that there is some savings, something meaningful, some meaningful benefit that they're getting from using digital technologies, they are now asking for more. So that's just a process I think that we'll all have to go through. But then talking about Demeter project, and so in the project we cover a lot of different use cases, and I'm responsible for a cluster of pilots that is dealing with transparency in the food supply chain. So what's typically called farm to fork. And what we try to do there is to capture the information about the production process, be it on a poultry farm, in a vineyard, and summarize it and make it available to other actors in the supply chain, eventually reaching the consumers, so that the consumers can get information, trustable information about how their apple was produced, how many times it was sprayed, and so on and so on. Eventually, maybe how much of the carbon footprint, what is the carbon footprint of such production, and so on. So this is something that is not that easy to create. I mean, yes, we do have a number of sensors, and we monitor what's happening on the farm, and we can collect all that information, but you don't want to provide all that information to everybody else in the supply chain. So you have to summarize it, you have to make it meaningful for other players, and in a form that is possible to transport and transfer between the stakeholders, and also understandable by all these different consumers, different stakeholders, including consumers at the end. And that will lead to those labels that we have on products, on food, so made in here, made in there, ingredients, all these things, how to make it more transparent, easily understandable by consumers. That is all part of this transparency. And then that will lead to circular economy as well, because once we can easily identify what is the content of that product, and we can trust that it is really like that, then we'll be able to decide what is the next step, how we can continue to use or use in another form that food. Is it just going to waste, or we can maybe repurpose it and make fish food or whatever other in whatever other form to use it. In this Target Smart project that we did a few years back, it wasn't about circular economy. It was about fast-moving consumer goods and giving the voice to those fast consumer FMCG goods. So enabling a bottle of water, an ice cream, a package of meat, enabling all these different packages to give us information about how they were produced, how they were transported, whether the cold supply chain was interrupted or not. And that we went through process of tagging individual packages of meat in a slaughterhouse and monitoring those packages of meat through the transports or in the trucks, eventually reaching the shops, the fridges, and having interaction with consumers. And that was something that was that attracted a lot of interest of the consumers, because they were able now to see, oh, look, this package of meat, it came yesterday, it was produced 2 days ago, it was transported in a proper conditions. And on top of that, they were able to get some additional information from the shop, and the shop was getting a digital channel to interact with the consumers. So there were a lot of benefits on different sides. At that time, it wasn't feasible commercially because the cost of tags was actually too high to have a tag per package of meat. But with the evolution of the technology, that will become more and more feasible as well. An interesting thing that we learned in a Target Smart project was about recycling. At that stage, I thought, okay, so recycling, yes, you take it and put it into a green bin, that's fine. So what's the big deal about it? And then we learned that it's actually not that straightforward. And for example, the deodorant can, the aluminum part, the big can, it has to go one way. The big plastic cap that goes on, it should go the other way. And the small thing, the plastic thing that you press, it should go to the third way. And because they're different materials, they should be recycled and processed differently. And we ran a big pilot on Mallorca. One of the partners there was driving it, providing incentives in collaboration with the shops for people to start recycling in that manner, to understand how to recycle and to do that properly. So these are all the different things that we have to take care of if we want to have this circular economy. It won't just happen overnight. There will be a lot of incentives will be required for people to start doing that, for companies to get involved as well, and also a lot of education. I think similar to what was said before about this communication gap between technology people and agriculture or farmers. I think it will be the same for all of us when it comes to circular economy. How we go from using something just once and reusing it multiple times, how to do that in a proper way. And just for the end, just a few things about what I learned actually recently during preparation of a project around this circular economy. So we were working with a big textile cluster from Sweden. And it's amazing how many things you can do with textile in the sense of reusing it, not just so selling it as a second-hand clothes, that's one thing. You can recolor it, you can completely refurbish it, basically move it back to the fibers and then use it again. So there are many different ways how you can use textile. And they say that at the moment, on top of the ground, kind of above the ground, we have enough textile for all of us forever almost. So we don't have to produce any more cotton almost to produce more clothes. If we were to reuse, recycle, and repurpose the textile that is available at the moment. What is missing are, to a large extent, digital tools that will connect all the different players and make that process of repurposing of textile more automatic and quicker so that it can be done on a large scale. Without such digital tools, it will be very difficult. The things can be done, but it will be very difficult to really make it massive.
Thank you very much for your ideas and what you shared with us. Let's go to the fourth. Our speaker is Dr. Sotiris Koussouris. Haris, your floor.
Hello, George. Thank you very much. Thanks also Athena and the organizers for the kind invitation. It has been my pleasure today to present you one of the use cases which have been conducted in our Center for Earth Observation Research and Satellite Remote Sensing of the National Observatory of Athens. I'm the last speaker. I know that time is valuable, so I will try to be very brief. But let me just highlight that. Let me just put it on a display mode. Okay, thank you. Okay, what is the Beyond Center of Excellence for Earth Observation of the National Observatory of Athens? We are acting in the area of the Earth observation. We are Earth observation scientists, and we are building big infrastructures for acquiring data and distributing data. It was a lot discussed today about the openness of data and big data. We are dealing a lot with big satellite data. Just to give you an idea, we have all the infrastructure, satellite acquisition, antennas and hubs, so as to be able to acquire more than 50,000 satellite images daily and redistribute into the worldwide, I mean, to the single user over the globe, more than 80,000 satellite images daily. So a lot of terabytes and petabytes on a monthly basis that are handled by our systems here. But at the same time, as we are scientists and as we are researchers, we are developing tools and processing capabilities so as to process mainly now and in the recent years on the cloud the data so as to derive innovative science and services for serving different domains like agriculture, disaster risk reduction, climate change, epidemics, and renewable energy resources. The last word on our center is that we are validated partner of the flagship space programs of the European Union, the Copernicus program. I'm sure most of you know this program. And we are regional support office of UN SPIDER, and we are assuming responsibility for the coordination of the Earth observation actions, the Copernicus and GEO actions over a big territory, including North Africa, Middle East, Balkans, and Black Sea. So having said that about our center here, let me just go through the use case, which is the exploitation of big Earth observations and artificial intelligence for food security monitoring. Here you see a small group of our center. The researchers that have conducted this research is Vasilis Konstantinou, an artificial intelligence scientist, Thanasis Rivas, an Earth observation system engineer, Alkiviadis Koukoulis, big data engineer, and myself assuming the coordination and the supervising of the group. Okay, let's give you now the picture why I have selected this use case. Because we do believe, and we all agree, I think, that balanced productivity and effective food security is strongly linked with circular economy in 3 dimensions: environmental protection, less wasteful production system, and economy and societal welfare. And how is possible now to be able to address all these topics? Actually, it is that we need, that it is required to have a timely and detailed information, crop-specific knowledge information at the very large scale. That means at the level of the country, at the level of the region, or even the continent, but at the highest possible spatial resolution. And this is what the Earth observation science is providing today. I mean, as a capability to us. We are receiving daily a lot of data, of high spatial resolution data, and we can have a continuous area monitoring, crop monitoring, starting from the single parcel level, from the single farmer, while at the same time it is providing the solution today and the technology today, and the data that we are receiving today, the possibility to integrate millions of farms, parcels, and farmers on a daily basis to get the picture at the region, country, or even continent level. And this is the big problem for us, the big data problem for us. problems. And the challenges, of course, because the challenges are to manage big satellite data, to cope with scarce label data, because in our processing of the data and clustering, classifying data, we need annotated data, labeled data, but in most of the cases, it was said several times today, the data are not available, or the data, even they exist, we cannot get access easily to them and in a federated manner. So we will try to solve this type of problem so as to be able to manage, classify, and cluster the data. And at the same time, of course, the challenge is to handle this big data through distributed machine learning, semi-supervised learning, and by exploiting, of course, and employing at the same time high-performance data analytics. The use case that I'm going to present you relates to South Korea. It is the mapping of the entire country, a monthly mapping of the entire country, providing to the stakeholders and decision makers in the South Korea paddy rice maps, and at the same time biomass and assessments and expected yield per field continuously. The food security problem in South Korea is rather complex, because the main problem there is the overproduction of rice. I mean, it's a lot of rice there, while at the same time this results in big problems which relate to large storage costs, underproduction of other major crops, and a state economy which is highly dependent on imports. So we devised a solution. It is developed, it is tested, validated, and nowadays used by the stakeholders in South Korea. But of course, it is a solution which is transferable, and this is the main objective and concept in all our solutions we are developing in the Earth observation era, that the solutions are using open data and that are transferable and scalable so as to address similar needs in other countries. So the solution we have devised, of course, it's a large-scale solution. It provides exhaustiveness in the monitoring of the fields. It's deriving crop mapping with high thematic accuracy so as to enable, as I mentioned already, evidence-based decision-making. At the same time, it is using open and reusable tools, and employs transparent and fully interoperable system architecture so as to be able to be used in other territories, European, non-European, global territories. And the main core features is that it enables to have a big data management. I mean, just to give you an idea, we are processing about 10 terabytes of Earth observation data and feature spaces with a dimension of more than 300 features. And this is on a weekly basis. This is done on a distributed processing environment in distributed computational environment. The solutions are low dependence, present low dependence on crowd truth information. As I mentioned, it's very difficult to have annotated data at the level we require so as to train to the extent we want and we need our machine learning approaches so as to provide the right and accurate classification and clustering of the data. So we have to solve the problem of scarce data, we have to augment the database of annotated information. And of course, the main core is to use, to the extent possible, generalized machine learning modeling techniques. So we want to have, and we have developed already, machine learning approaches which are of generic use so that they can be interoperable and transferable at global level.
Haris, sorry for interrupting you because the time is very limited.
I understand. Okay. I go directly to the services and with this I close. Okay. Okay, here on that slide, you'll see how we have matched challenges with solutions. I mentioned already. We employed HVDA approaches in two ways, for distributed storage and distributed processing. These are the three services that are available today and distributed to the stakeholder community, to the decision makers, and to the farmers, to the sink farmer in South Korea. The services are rice paddy mapping on a monthly basis. So you see month by month what is the production of rice in the whole country. The rice status indicator, I mean, this is a very important, it's a very innovative information because you can see at the level of the single parcel what is the health of the plant, the phenological state of the plant, and based on that and the history of the plant, to be able to have biomass and yield indicators month by month, forecasting the yield until you get to the final and of course yield production at the single farm level, which integrated at the number of farms in the country, it can give the whole yield assessment at the level of the country. Thank you very much for your attention. A lot of information can be found on our website, the website of the Beyond Center of Excellence, and I will be glad to reply to any question today or, I mean, in the following stage that you would be interested to learn more about. Thank you very much.
Thank you very much, Haris. It seems that we are behind the time, but it seems that all the 4 use cases that you presented highlight the opportunities for boosting data-driven circular practices towards innovative digital transformations. I would like to thank you, and I will conclude this session.
Thanks a lot to the moderators and to all the speakers. Indeed, very, very interesting and exciting presentations. Really inspire a lot of ideas for future directions. We are definitely behind the schedule, but we would like to invite the audience to our last open discussion and artistic intervention in the conclusions of the workshop. Just stay with us a bit more after 1 o'clock as was planned, because we do have to share with you some very interesting and we believe creative conclusions. So I will give the floor to the moderators of our last session, Dr. Vasilis Psomiadis and Dr. Nicoleta Tandalaki. They are both postdoc researchers in our data lab, and they are really the ones who made all of this workshop happening. I'm grateful to them for their hard work. They worked really as a dream team together, and we are grateful for their work. Together with Hanne-Louise Johannesen from Diffuse, they will conclude the workshop, and we all remain here for answers and discussions. So the floor is yours, Vasilis and Nicoleta.
Athena, as a co-host, I think you need to allow me to share my video.
I will do that.
Okay.
Okay, thank you.
Thank you, Sina. Yes.
Okay. Hello. I'm glad to meet all of you here today. I would like, first of all, to thank our speakers for bringing their expertise and experience around the table and engaging in such fruitful, constructive, and open exchanges throughout this workshop. So I would really like to thank all of you for your time and your valuable insights. Now, I will let Hanne-Louise from Diffuse Design to provide us with her own creative perspective on the various digital circularity enablers that our speakers shared with us earlier today, while I'll try to summarize some key issues. So, Han, what would you like?
For some reason, I cannot share that the phone, but
now you're unmute. Yeah, you're muted, and we can see the camera.
Hanne-Louise, you are muted. Can you please unmute?
Yes, for some reason I'm. Can you see the table?
We see the camera.
Okay, perfect. Yeah, perfect. I just need to pin here. Yes, sorry. I'm ready. Please go ahead.
Okay, so let's start. So, In response to the transition from the traditional economic model that most of you probably know of take, make, consume, and waste, which thrived during the Industrial Revolution, to the circular economic model, which is based on the reuse of resources, the regeneration of natural systems, and aims to reduce waste and pollution, we organized this workshop. Traditional industry sectors experience nowadays an artificial intelligence transformation, and then workforces will definitely have to adapt. As the world becomes increasingly digitalized, demand for data center services is rising rapidly. Global internet traffic tripled, and data center workloads more than doubled. However, rapid improvements in the efficiency of servers, storage devices, and data center infrastructure, as well as a shift away from small, inefficient data centers to larger and more efficient cloud and hyperscale data centers, have helped to limit electricity demand growth. So, as an example, we talked about a sophisticated telecommunications network based on LoRa, a low-power, wide-area network modulation that was established by the American Farm School in primary production facilities to support a key sector for the Greek economy. This network offers capabilities for digital interconnection and remote monitoring of primary production, standardization, and processing facilities, as well as transport activities, providing an important step forward to all those involved in the agri-food sector and supply chain. Technologies like the Internet of Things, computer vision, and blockchain ledger technology have also been exploited by Montenegro to contribute to the digital transformation in supply chain with a focus on product traceability. Food safety and food supply chain applications of these technologies proved to improve end-to-end visibility and tracking and tracing food products through their life cycle. Recent advancements in data-driven decision-making and performance analysis can also provide another sector that we talked about, the wastewater treatment industry, with an opportunity to reduce costs and improve operations. Optimization of wastewater techniques, reduction of the environmental footprint, and improvement of wastewater derivatives are direct gains, whilst new commercial opportunities and business models can also be created. The practice of big data collection mentioned so far definitely raises concerns over access and security. However, the ability to conduct large-scale and big data-oriented research strongly depends on a key factor. Vasilis, would you like to tell us more about it?
Thank you, Nicoleta. From the discussion so far, it seems that one crucial factor is the availability of data. Insights provided through open data can improve the decision-making on the efficient use of resources, since, as we know, data can help predict certain trends, like market trends, weather, demographics, and so on, of future supply and demand. Consequently, public entities and organizations should be encouraged to share their valuable data while respecting user privacy, possible trade secrets, and intellectual property. The importance of novel and advanced data sharing and data analytics methods in the cloud continuum, from edge to the fog and to the data center, was also highlighted for the transition to circular economy models. These technologies can provide additional value to data owners and data users by offering high availability of data, security and trust properties in data handling, but also low latency processing and data-driven intelligence. Earth observation data and services, which present many big data and data analytics challenges, as we saw, were also showcased and how they can disrupt agriculture and the overall food value chain. A very critical sector, I would say, for circular economy. The basis of a circular economy is a zero-waste society, where everything that we produce and consume can return safely to nature or the society itself. The concept of zero defect and zero waste production should be embraced across all countries. But to facilitate its implementation, we will certainly need appropriate strategies and technologies adopted, as well as policies and standards to be implemented. Towards this direction, we also listened to how plastic waste aims to evaluate plastic waste and consider it as a valuable asset for the development of innovative products and services that will allow its re-entrance into the real economy instead of filling landfills and our oceans. I think it's clear that we need a data-driven intelligence and data-driven culture to support the transition into smart, sustainable, circular economy business processes. Data science and AI drives the emerging skills needed by both industry and society at large. However, as we discussed earlier, there is a skills gap when it comes to data and AI. We need not only to train IT professionals, but also to train interdisciplinary experts and ensure non-expert users have a basic understanding and awareness of these AI systems and how they operate. We require organizations that connect the supply and demand for AI assets and researchers that investigate new algorithms, novel hardware, new technologies and methodologies and business models. So the involvement of all stakeholders, including citizens that are part of this circular value chain, has been identified as a key success factor to this transition. And also, I would like to extend my thanks to Hanne-Louise for this really creative and inspiring visual summary of all the key takeaways of our later sessions. Many thanks, Hanne-Louise, for everything. Now, although we don't have much time, I would like to ask, to extend some questions to our experts based on the earlier discussions and presentations. A first question for you, Ernestina. In your presentation, you highlighted the data skills challenges and opportunities of this digital circular transition. Do you see that if the European value chains and in the modern sense also our own societies are prepared to embrace this AI and data-driven innovation?
Ernestina, you're muted. We can't hear you.
Perhaps, Athena, you can try to answer the question.
Yes, how ready we are, let's say, and indeed, I think this is really a challenging topic. Actually, I share several of the concerns raised, especially by Philippos and all of the panelists we had in their sectors. And definitely, I would emphasize that we need interdisciplinarity to work more, I would say, hand in hand, because indeed what happens in the research work should not be closed, let's say, in the academia bubble. It should go out there. And definitely I also share the idea about the career pathways and not just skill sets. Also, citizens should be in the loop, as Hanne-Louise indicates with your very nice drawing. So definitely, I think this was highlighted in the workshop. Thank you, Vasilis.
Thank you very much. Artur, can you hear us? I have also one question for you.
Yes, I'm here.
Okay, yes. Great. As we are already aware, and from the presentation and the other presentation during the workshop, there are currently quite a lot of initiatives going on with regards to open data and data spaces in Europe. Also, we know that new regulatory frameworks are being launched by the European Commission. Could you give us a perspective on what should be prioritized in the coming years to ensure wide availability and access to public open data? From your side, what do you think?
Well, maybe I will take the opportunity to emphasize something that I didn't mention, but it's very, very relevant right now, which it's the new Data Governance Act that tackles, I would say, the missing points on the previous regulation that still raised questions about how public entities, and not only public entities, also private ones, should address the data sharing issues that they may still have regarding confidentiality and the barriers that they see in sharing their data. So I would emphasize that along with all the ethical AI initiatives that are also going on right now, because I would say that in the end, the convergence or the mix of data and AI, it's a must, of course, because AI doesn't have any meaning without quality data and without availability and constant flows of data. So I would say that these two trends, these two pathways that we have in front of us are mostly relevant for the future, not only in the circular economy that we have been here addressing today, but in society at large, in European society at large. So I would go for those two.
Great, thank you for your answer. Sotiris, in your presentation, you displayed the value of data assets handling in the cloud continuum for secular services. Based on your experience in the field, could you provide us with an example how data intelligence on the edge could be utilized?
Yes, I missed the last word. The data intelligence on the edge could be?
Utilized.
Utilized.
Yeah.
Okay.
Some sector or some domain that you have experience with this.
Mm-hmm. Okay, actually this is something that is quite relevant to the manufacturing domain because as we have seen from various projects that will take place and also from some commercial applications, there is a need for, in this domain, to keep certain intelligence on the edge. So I'm just, now taking only the perspective that has to do with privacy and actually data sharing. And in that domain, there is a very big reluctance to share all this data over the cloud and perform their operations, mostly due to the fact that people don't actually trust at 100% that the data that is transferred there and is managed there is secure. So in such a domain, analytics at the edge and data handling at the edge is quite something that we see relevant. Also, this has to do with infrastructure that call for low latency. This could be again, in manufacturing environments where you have robots that do have sensors, which should instantly take some decisions, for example, to stop their operation or rapidly, neutralize the production machine in order not for damage to be, to be made, even to the machine itself or to, a human that is walking by and within the limits of the machine.
Great, thank you for your answer. Lelia, I got one question for you also. We heard that in plastic tweets, engaging all actors of the value chain, and especially citizens, was one of the key aspects to make this transformation feasible. What is the model that you used in plastic tweets to engage stakeholders and to make them exchange and create open data and innovative plastic review solutions based on this data?
Thank you, Vasilis. It's a very good question, in fact, because the real success of the Plastic Twist project was about bringing together the users, the citizens, and different people from different competencies. But here, and also we had pilots in the project from 3 different countries. And these 3 pilots were from different, were participating from different use cases, Fab Labs, the activists, and the plastic entrepreneurs and young people as well. And but I think but it's also a result of our academic article that was recently published, that the grassroots initiatives were very important. The communities, the citizen communities and grassroots initiatives participation had been very valuable in the project, because what we are doing is about the communities. It's a global issue, and it should be tackled locally. So, and data is created. Data is in the activities and movements of people. So it is very important that people would participate and share what they need and what can be done, and involved in the processes. So the answer was the involvement of grassroots initiatives.
Thank you, Leila. Thank you very much. And one final question towards Athena. Athena, today we listened to many insights and discussed a lot of concrete examples within various domains where cutting-edge data technologies contribute towards this digital circular transition. And if we wanted, let's say, to keep just one solid takeaway of the whole Regain workshop, what would that be, in your opinion?
Well, I'm really glad we have now came to the stage to conclude with Regain. Well, I would say that Regain is about what we all gain. In the sense that there have to be win-win solutions. So we need, let's say, green data-driven culture. This culture will really come up with synergies from all over the ecosystem. So we need all stack technologies from cloud, fog, edge, to join, let's say, solutions, and these solutions should impact all the critical sectors. We had today so many interesting farm-to-farm solutions, earth data-driven solutions, definitely for several sectors like in manufacturing, definitely the plastics impact, and certainly the whole agro domain, let's say, has a lot to gain along with manufacturing, water, and so on. I know it was not a brief motto, my answer, but definitely we have to deal with all of those challenges. And if you all spot your view at what Hanne-Louise is displaying with her video, I believe all of these visuals are really, really inspiring for the next steps. And again, I'm grateful to all our colleagues and friends. We have joined so many efforts together, and we hope this was useful for the whole audience. So I think we can close the workshop here, or maybe, I don't know if any of the participants would like to make a comment, of the panelists, of course.
Certainly.
Well, once more, thank you again, the organizers, you, Athena, and Vasilis, for the great help. Thank you very much for the invitation. And it was a great meeting. Thank you very much.
Thank you, Haris. Thank you all.
Thank you very much.
So we hope we all meet soon.
Physical.
Indeed. Let's meet in Greece.
Bye-bye.
Bye-bye.
Bye. Thank you.
Bye.
See you next time.
Thank you, Hanne-Louise. Bye-bye to all.
Bye.